everyone. This is lesson 11.8 on surface area and volume of spheres. This is going to be a pretty short lesson because there's only two formulas that you need to know, and you hardly need a lesson on this, but just to get the formulas and see a few examples. So that's all we're going to do. So here are just some basic vocabulary. This should be nothing really new. Hemisphere is just half of a sphere, so we're working with spheres, and you've got the radius of the sphere, diameter, same things that apply to the circle and things that you've probably already seen before. So one thing that you might want to do is know how to draw a sphere. So if you draw a sphere, you draw a circle, and then you draw a little arc here, and then a dotted arc for behind it. So that way it kind of looks like it's in 3 dimensions. So the surface area and volume of the sphere are related. So the surface area, just like circumference and area equations are related. For surface area, it's 4 pi r to the second power. And then for volume, it's 4/3 pi r to the third power. All right, so it's not actually a coincidence that when you raise the exponent by 1 from 2 to 3, you also end up dividing the 4 by 3. That is actually a thing with calculus. To get from a second dimension to a third dimension, you would do something what we call integrate, and that means that you raise the power of the exponent by 1, and you divide by whatever that new power is. So I know I'm not expecting you to understand calculus right now, but that's a way you can relate in your head the difference between them and which one gets the 4/3 and which one gets the 4. So surface area gets the 4, volume gets the 4/3 because it's r to the second power. All right, so example, and I'm not even going to plug it in. You can plug it into your calculator and get the decimal. So for this one, surface area would be 4 pi and then 7 squared. Volume would be 4/3 pi times 7 cubed. Okay, so super easy. This one, same thing, just divide the diameter by 2. This one, okay, so volume, you would just take the regular volume and divide it by 2. Surface area is a little bit different because you're going to do half of the surface area, but then you also have to add the top portion. So it would be basically instead of 4 pi r squared, you're just going to do 2 pi r squared because you're doing half. So 2 pi times the radius would be 10.35 squared. And then you're going to add that to the area of the top part, which is just an area of a circle, pi r squared, 0.35 squared. So really you end up with 3 pi r squared if you add those together. So type that in your calculator and get the answer. Number 4 is absolutely nothing different. Neither is number 5. Number 6, I guess, just when you take r squared, you're going to do 14 squared, and that would give you just 14. If you're doing the square root of 14 cubed, that would give you 14 times the square root of 14, because although you can cancel out 2 of them, you still have 1 square left over. So it's like square root of 14 times square root of 14 times square root of 14. Okay. For this last one, so volume, you would get the volume of half of a sphere, volume of the cylinder. So volume of half of a sphere would be 1/2 of 4/3 times pi r cubed, so 6 cubed. And then add that to the volume of the cylinder. So area of the base times height, pi times 6 squared times 4. And then for the surface area, you're going to do just half of the surface area of a sphere. So that would be 2 pi r squared. And we don't need to add this circular portion because it's not part of the surface. That part is in the middle, it's hollow. And then you're going to add that to the surface area of cylinder, which for the base, you would just do pi r squared. So pi times 6 squared. And once again, you're only doing one base because you don't have two bases in this example. And then you're going to add the lateral area, which you get by taking the circumference and multiplying it by the height. So the circumference would be 2 pi r, so 2 pi times 6, and times the height, which is 4. Okay, so type that all in your calculator and you get the answer. Okay, so that's all the examples that were in the notes. That should do you well with the edge elastic that you'll have on Monday. Okay, you guys have a great weekend.